Alright, so we're gonna discuss something about something which is called as a unit circle. In a unit circle, if you notice, I've already made the quadrants over here. Always remember this whenever we are going to count the measures in the anti-clockwise direction, all the angles. So that's when we consider theta to be positive, and if you're going in the other direction, that means in this direction, theta will be negative. Alright, so I'm only going to consider for the positive angles now, and according to the positive angles I've already marked it as 0, 90, 180, 270, and I'll be discussing everything in radians, sorry, in degrees and not in radians. Okay, so before we begin, just a quick thing about right angle triangle. So in the right angle triangle, if you know this, so everyone should be knowing this. This is the hypotenuse, this is theta, right? So this will be the opposite, and this will be the adjacent side, correct? So what I've considered here is a unit circle. Unit circle means the radius will be 1. Okay, next, so over here if you notice, this forms a right angle triangle over here. Okay, for this right angle triangle, this angle is what I'll be considering as theta. Okay, next thing, so if I want to find sine of theta, correct, sine theta would be the opposite upon the hypotenuse. So opposite would be y value, because this is y and this is x. So sine theta will be y over x. Sorry, this will be y over the hypotenuse, and the hypotenuse is 1. Okay, so that means y is what I can call it as sine theta for the unit circle, and this is cos theta will be x over 1. That means x is equal to cos theta. So that means every x value will be associated with cos, and y value will be associated with sine theta. Okay, so if I want to start with the sign conventions, okay, sign convention, that would imply that wherever x is positive, that's why cos theta will be positive, and wherever y is positive, the sine theta values will be positive. So that means in the first quadrant. Now, with how do we label the quadrants? Because theta is counted positive if you're going in the anti-clockwise direction, this becomes the first quadrant, the first 90 degree. Then from 90 to 180, this is second, this will be third, and this will be fourth. So now when we are discussing about the sign conventions, so in the first quadrant, if you notice, the sine theta value will be positive, sine is positive, cos is positive. So that implies that the tan will also be positive. In the second quadrant, if you look at it, right, the x values are negative, but the y values are positive. So that means the sine value will be positive, cos value negative, and tan value will also be negative. Same way, if I go in the third quadrant both x and y are negative, so that means sine is negative, cos is negative, and but tan theta will be positive. And in the fourth quadrant, cos theta is positive, so that means sine is negative, cos is positive, and tan is negative. So this gets us to the next to the so easier to make it easier to remember, we write it as A S T C. Okay, so ASTC, A means all are positive, sine, S means sine is positive, T means tan would be positive, and fourth quadrant cos is positive. To remember this, the easier way would be all silver teacups. Okay, all silver teacups, or all students take calculus, add sugar to coffee, whatever way you want to remember it. Okay, next part. So next we're gonna talk about how to calculate the angle in every quadrant. Okay, so as we have already discussed the part wherein the sine theta and cos theta, wherever there's sine theta, right, the y values that goes with sine, and the x values go with cos. Okay, so let's discuss about an angle in the in the second quadrant. Okay, so here we go. This value. Okay, so if I want, this is my theta. So for this theta, what is happening is there is no right angle triangle that can be formed in an obtuse angle triangle, isn't it? So what do we do is that we form a right angle triangle on the other side. Oh, never mind. Okay, so you form a right angle triangle on the other side. So if this is theta, then this angle will be, let's label it as alpha. Or I think I should better work with an angle over here. Okay, so let's say theta is 120. So that means the other angle that will be 60. So I want to find sine of 120 and cos of 120. So to do that, it will be much easier if I can find the coordinates of this in terms of the 60. So if I'm only considering the triangle, alright, so for this triangle it's a unit circle, so that means the hypotenuse is 1. Alright, the x value that is there, x value will be cos of 60, sine of 60. But in the previous part, what we saw about the sign convention, that in the second quadrant the x values are negative, so that means over here I will get it as minus cos 60 and the y value will be sine 60, because second quadrant sine is positive. So this is what I'm getting. Now this coordinate x and y will remain the same, either I'm looking at it as the smaller triangle or if I'm looking at it as the whole 120-degree angle. Okay, so the easier way to write this, whenever we have sine of 120, it could be easily written, it could be written same as sine of 180 minus 60, which will be same as sine 60, as it is lying in the second quadrant. The the sign convention will be positive. But if I'm looking at cos of 120, this will be cos of 180 minus 60. This will become negative cos 60. Alright, I hope this makes sense to everyone. I'm going to simplify this for any angle in any quadrant. Okay, how do we do that? See, in the second quadrant, okay, for the trigonometry ratio is not changing, right? So this angle that is there, if I'm taking this as theta, this is theta, so this angle I'll take it as alpha, just for our convenience. Okay, you can take it as any angle. I prefer to take it as alpha. So whenever you want to find cos of any angle in the second quadrant I'm talking of, so it can be written as cos of 180 minus alpha value. Now what is alpha? Alpha is the acute angle value, which it makes with the x-axis, acute angle with x-axis. Okay, and this value, if it's in the second quadrant, then this will be same as negative cos of alpha. Alright, similarly, if I'm talking about sine theta in the second quadrant, it will be same as sine of 180 minus alpha, which will be sine alpha as it is. Okay, so to make it easier, what I'm going to do is that I'm going to summarize everything, okay, for all the quadrants, and then if there's any help needed, please post in the comments. I'll help you with that bit. Okay, so theta is same as alpha. Over here, theta will be equal to same as 180 minus alpha. Okay, and in the third quadrant, theta will be same as 180 plus alpha, and the fourth quadrant, theta is equal to 360 minus alpha value. Okay, always remember this whenever you are going 180 plus alpha, right? So whenever you are using the x-axis for the sign convention, in that case the trigonometry ratio remains the same. Now in some other video I'll be mentioning that if you are dealing with the y-axis, or if you use the transformation with respect to the y-axis, the trigonometry ratio changes to its counterpart. That is something is for the other video. Okay, so always remember this as a summary. Whenever you're finding any trigonometry ratio, right, there are two things that you need to know. The first thing is that find out the quadrant in which the trigonometry ratio is lying, and the second thing that you'll remember is the acute angle value, acute angle alpha with positive x-axis. Okay, lastly, what I'm going to do is that I'm going to just give you one small example and then end the video. If I have, let's say, sine of 210. Okay, how do I find this? So sine 210, if I it's a third quadrant, so I can write it as 180 plus 30. If I write it this way, this will be same as negative sine of 30, which is negative 1 over 2. If I use cos of 210, this will be cos of 120 plus 30. This can be written as 180 plus 30, which will be negative cos 30, which will be negative root 3 over 2. Alright, now the other way around, I know I'm giving one more example, is that if you are given cos theta is equal to negative 1 over 2. Alright, so how do you find theta? To find theta, we can first discuss where is cos theta negative. Cos theta would be negative in the second, mhm, in the second and in the third quadrant. Cos theta is negative. So, in if I want to find a second quadrant value for theta, right, I will be using 180 minus the alpha value, and if it's in the third quadrant, I'll be using theta is 180 plus the alpha value. Now to find alpha, what I'm going to do is that I'll consider the ratio without the negative. So that means cos of alpha I'll consider to be 1 by 2. Okay, so what will be the alpha value if it is 1 over 2? So cos alpha 1 over 2, that is at 30. No, it is at 60. So this will be 60 degrees. Okay, so I know the alpha value to be 60. So theta will be equal to 180 minus 60. That means theta is equal to 120, and over here theta will be equal to 180 plus 60. Theta will be equal to 240 degrees. I hope that makes sense. That's it for today. All the best.